Hi there. Thank you for joining us today. For Computer Science 6440 Health Informatics class project, we built MedChat, a personalized AI-powered medical chatbot designed to assist patients by answering their health-related questions using data from electronic health records. For the next 15 minutes, we will walk you through the project's background, implementation, demonstration, and future direction. MedChat was created to solve a critical gap in patient care: the lack of tools that provide both accurate and personalized medical information to the patients. Our chatbot integrates medical data from electronic health records, EHRs, using smart on FHIR and leveraging OpenAI LLM for generating accurate and relevant responses that patients care about. Therefore, MedChat is able to provide private, reliable, and customized responses for patients. So let's take a closer look at the architectural design. The chat application interface is built on top of Streamlit, an open-source Python framework for building and deploying interactive, data-driven web applications. Through RAG, Retrieval Augmented Generation, the system pulls FHIR data and feeds LLM contexts for questions. And then, in the middle here, we use LangChain, a tool that can chain together language models and the Streamlit chat interface that also help manage RAG pipeline and to train messages to fit LLM context size requirements. As for user authentication, we use Smart on FHIR. We choose to use OpenAI as the large language model behind the chatbot for economic and time efficiency reasons. We also use Tokenizer to ensure that the model's input is tokenized in the same way as the model was trained. So now let's head to the chatbots for a full demonstration. Here is the login page. We use Smart on FHIR for authentication. This allows patients to securely log in using their credentials. A list of credentials of the demo users was provided for testing purpose. As you can see here, if you click on the drop-down list, we have provided several test users. Each user here has a specific condition, so we will be able to test different scenarios if needed. Currently, we have conditions, demographics, diagnostics, medications data available. Also, as you can notice, we customize the MedChat avatar to make it look visually more appealing to the users. So now if we click on Login with ArcoHealth, this will bring us to the MedChat interface. To save us some time, let's use this page where I have already loaded just to save us some time during this presentation. So assume now we're logged in. FHIR resources are loaded from the Sandbox FHIR server and added to a vector database. As the user, you are brought directly to this chat interface. Here you can ask general medical questions like, what is normal BMI for adult male? So let's give it a try. So the response we get here is a normal BMI for adult male is typically between 18.5 and 24.9. You can also ask individual specific questions like, what was my BMI? Or based on my BMI, can you give me some advice and tips? So let's try that. So, as you can see, MedChat's response are, your BMI values range from 20 to 70, with the most recent reading indicating a normal interpretation. However, the highest value suggests morbid obesity. It's important to discuss these results with healthcare provider for personalized advice. And then as for tips and advice, it has provided several tips and advice to help the user to stay fit. In addition to these questions, if you're interested in medication history conditions, you can also ask MedChat directly for some quick and reliable answers. For example, let's give it a try. So as you can see here, regarding medication history, MedChat has provided the detailed information about the medicine this patient was prescribed. And as for procedures, most likely because we do not have, this patient does not have the details on procedures, therefore the MedChat is just going to reply that there are no additional details regarding your procedures. So this is when RAG, retrieval augmented generation, really comes into play. MedChat can give you personalized answers, as FHIR was used to pull health data from electronic health records, EHRs, and then feed this data into the prompt for LLM. Another feature that I want to show is if you try to ask a non-health related question, MedChat would actually abstain from answering in order to keep the conversation in the medical zone that the model was tuned for. So, for example, if you ask, what is the capital for Germany? Let's see what will MedChat reply with. So the response was, I'm here to provide health-related information. If you have any health questions or concerns, feel free to ask. So this is a quick demo on MedChat. If you're interested in giving it a try, please feel free to access this chatbot through the link provided on this slide, and you should be able to access it. And then all the information of the demo users are provided on the login page. Here I have included a few screenshots of how to access this chatbot. As for research we did during development, and also as for retrospective, we did spend a lot of time researching in order to implement Smart on FHIR, a framework that allows secure patient data retrieval from EHR. We also utilize RAG, and although RAG was also discussed in the class, we have extended quite significantly during our projects. Also, for persistent vector storage was handled using ChromaDB, which ensured scalability and efficiency when managing patient data. we have also did some additional research on how to utilize that for our projects. During development, we faced several challenges that required creative problem solving and adaptability. Oracle Health Smart on FHIR Sandbox had sparse documentation, so how to obtain authorization endpoint URL was unclear. This forced us to rely on archived discussion on some forums to configure authentication. Additionally, Oracle Health unexpectedly altered their sandbox environment in the second last week before the due, causing a no records available error when accessing demo patient data. To resolve this, we implemented vendor-agnostic Smart App Launch Framework, enabling compatibility with any FHIR sandbox server. Further, ChromaDB used for persistent vector storage caused silent crashes on Windows due to file handling issues. Extensive debugging revealed that the need for manual directory clearing and then error tracking as temporary fixes. These challenges existed in all components: Smart on FHIR, ChromaDB, LangChain, and OpenAI, and each requiring precise configurations to ensure seamless operation. Despite these obstacles, we were able to develop MedChat that is both robust and reliable. As for some potential future work, it includes but not limited to further expanding MedChat's functionality by incorporating even more FHIR resources, such as immunization, nutrition order, and insurance plan, etc. This can help provide deeper insights into patient health. Additionally, developing robust evaluation metrics will help us ensure the chatbot's accuracy and reliability. That also stays on our to-do list. Also, besides current version that's mainly for patient use, MedChat has the potential for professional applications, such as assisting healthcare providers in monitoring patient data. In summary, MedChat helps with improving patients' access to personalized and reliable medical information. By combining LLM with secure EHR data integration, we have created a tool that helps patients to make informed health decisions. Thank you for your time, and we appreciate any feedback. Please do not hesitate to reach out to us. Again, thank you.